The arrival of 3 Atlas, the day the sky went on alert. Something remarkable happened, quietly at first. NASA had just switched on its full planetary defense network, a system most of the public didn't even know existed. But this wasn't a drill. It was a response to something no one had ever seen before, a mysterious interstellar traveler known as 3 Atlas. When astronomers first noticed a faint moving light in the constellation Pegasus, it seemed insignificant. Just another icy fragment at the edge of the solar system, beyond Neptune's orbit. But within days, the data changed everything. Its path, its speed, its strange reflective glow, none of it made sense. It wasn't bound to the sun by gravity. It was slicing straight through the solar system at over 60 kilometers per second, faster than anything natural we'd ever recorded. This was no ordinary comet. Its orbit was hyperbolic, a one-way trajectory from deep interstellar space. In a few short months, it would pass through our cosmic neighborhood and vanish forever. It became the third known interstellar visitor after Oumuamua and Borisov. But its size, speed, and energy output made it unlike either of them. When word reached NASA's Planetary Defense Coordination Office, the response was immediate. For the first time in history, the entire planetary defense system, designed to track dangerous asteroids, was activated for an object from another star system. Ground-based telescopes, orbital sensors, and radar networks around the world were synchronized into a single system. Antennas from the Deep Space Network locked onto the coordinates first detected by Hawaii's Atlas Observatory. Soon, the Minor Planet Center confirmed the trajectory. It would pass within 0.8 astronomical units of Earth's orbit, close enough for concern, but safe enough for study. Suddenly, the world was watching. The European Space Agency, JAXA, and observatories from Chile to Australia joined the effort. Supercomputers at NASA's Jet Propulsion Laboratory began modeling the object's spin, density, and temperature as it neared the Sun. The data was astonishing. 3 Atlas wasn't just ice and dust. Its surface reflected light in strange, uneven patterns, hinting at metallic layers and organic compounds beneath volatile ices. Radar scans revealed density shifts and fractures that didn't match any known comet or asteroid. Some researchers speculated it could be debris from a destroyed exoplanet, or perhaps something far older, far stranger. NASA remained cautious. No direct signs of technology were detected, but the curiosity grew. Every telescope, every antenna, every radar pulse was stretched to its limit. Systems designed for planetary defense were now doing interstellar science. Across the world, universities and small observatories joined in. Students were processing real-time spectral data. Classrooms turned into mission control centers. For the first time, learning and discovery were happening on a global scale, united by a single cosmic mystery. Chemical readings told their own story. There were traces of silicon metal compounds, organic molecules, and frozen volatiles, suggesting that this object had once belonged to a world that had undergone geological evolution before being ejected into deep space. 3 Atlas wasn't just a visitor, it was a record of another solar system's history. As it neared the Sun, its surface flickered with bursts of outgassing, revealing hidden pockets of vapor and reflective crystals. Its tumbling motion and complex shape forced astronomers to recalibrate their instruments again and again. Every second brought new data, new mysteries. The event proved that planetary defense and exploration are deeply connected. By studying this harmless interstellar visitor, humanity was practicing for the day when something far more dangerous might appear. Knowledge itself had become a form of protection. The cooperation between nations, scientists, and defense agencies was unprecedented. For the first time, classified radar systems once meant for military use contributed to public science. Boundaries between defense and discovery blurred, replaced by a shared pursuit of truth. Philosophers and scientists alike began asking new questions, questions that reached far beyond the realm of science. What does it truly mean to defend a planet? Is planetary defense simply the act of avoiding destruction, or is it something greater, an effort to understand the universe so deeply that ignorance itself becomes impossible? For centuries, humanity looked to the stars for guidance, for meaning, for stories. Now, for the first time, we were looking with purpose, not only to survive but to know. To study the heavens became an act of responsibility. Every radar pulse, every telescope image, every spectral reading, all became part of a greater promise, that we will never again turn away from the sky that made us. Watching the cosmos was no longer about fear. It became an act of reverence, a way of honoring our fragile world by understanding the vast one around it. Because every discovery out there reflects something within us, our curiosity, our courage, our will to reach beyond the known. When 3 Atlas finally crossed the orbit of Earth and continued its long journey into the interstellar dark, it left behind no harm, only knowledge. But in that knowledge was something far greater than data. It left behind inspiration. It left behind unity. For the scientists who worked through sleepless nights to track it, 3 Atlas was not merely an object, it was a teacher. It reminded us that vigilance and curiosity are not separate forces, they are two sides of the same instinct that built civilizations and telescopes alike. The very systems we built to protect our planet became instruments of discovery, proof that defense and exploration are forever linked. As 3 Atlas drifted into the cold beyond, its faint reflection vanished from our sensors, but its story did not end there. In labs, observatories, and classrooms, its data continues to spark new ideas. It inspired the design of autonomous space observatories, capable of reacting within seconds to new cosmic threats. It fueled the creation of AI-driven telescopes, systems that learn from the past to predict the paths of tomorrow's interstellar visitors. It even changed how humanity sees itself, no longer as isolated beings beneath a distant sky, but as guardians of a shared cosmic shore. 3 Atlas taught a timeless truth. To protect the Earth, we must first understand the universe that surrounds it. Every comet, every asteroid, every fragment wandering between the stars carries lessons, messages written in dust and light, waiting for someone to listen. And maybe, just maybe, in listening to them, we are also listening to echoes of our own beginnings. Because we too are travelers, atoms once forged in dying stars, now awake and aware, asking the universe where we came from and where we are going next. So when we look up at the night sky, each flicker of light feels different now. Every star, every passing object, is no longer a mystery to fear but an invitation to learn. A silent reminder that curiosity is our greatest defense, and wonder our most enduring strength. 3 Atlas may be gone, but the legacy it left behind is written in the minds of those who dared to ask why. It united nations, inspired technology, and redefined what it means to watch the heavens. It proved that the greatest discoveries are born not from power, but from persistence, not from fear, but from fascination. And so, as humanity continues to look upward, we remember what 3 Atlas showed us. That the night sky is not an empty void, but a living history, filled with travelers, stories, and cosmic memories drifting endlessly between the stars. Every glimmer is both a warning and a whisper. A warning that the universe is vast and unpredictable. And a whisper, that in understanding it, we come closer to understanding ourselves. Because in the end, exploration never truly ends. It simply moves from one horizon to the next, carried by the same light that first taught us to dream.